So, let us go back and write the equation in x direction. P1 A1 is the pressure in x direction minus P2 A2 cos theta plus Fx. This is the net force on this fluid element which is enclosed between section 1, 2 and 3, 4. This force is acting in x direction on this control volume. Now, this force is equal to rate of change of momentum. Now, rate of change of momentum of the system, this force is equal to rate of change of momentum of the system, but since we are applying for control volume, it means that this was for system and this is for control volume, both are same. Now, if flow is a steady flow, then what is dVCV over dt means rate of change of momentum for control volume. Since flow is steady, so it means properties do not change with time. So, that momentum inside the control volume also will not change with time. So, this is equal to 0 minus momentum going inside the control volume plus momentum going outside the control volume, right. So, force is equal to this thing, but in this case we have a control volume. So, this is replaced by these 3 terms. In this case the first term will become 0 because flow is steady. Now, we are left with 2 terms minus B in plus B out. What is B in? Momentum going inside the control volume minus B in, momentum going inside the control volume. This is the momentum going inside the control volume. So, this is mass multiplied by velocity at which it is going inside the control volume. So, this is minus B in, minus B in plus B out, B out in the direction, since momentum is a vector quantity. So, we have to take care of the direction. This is the momentum going inside the control volume in x direction, because V1 is in x direction, but V2 is in some other direction. So, we have to take component of this momentum in x direction only. So, minus B in property in, or that is momentum in, plus B out, that momentum is out. What is momentum going outside the control volume in x direction? It is mV2 is the total momentum, but in x direction it is mV2 cos of theta, because we have angle theta here. So, in this manner we can write the momentum equation in x direction. So, let me again repeat this. What is this thing? These 3 are the forces in x direction on this control volume. First we have to select the control volume, then we have to find out the forces acting in x direction. So, due to the body force and surface force, and after knowing these forces in x direction is equal to rate of change of momentum of the system, but rate of change of momentum of the system is equal to these 3 with the help of Reynolds transport theorem. Since flow is a steady flow, so this term will become 0 and we are left with these 2 terms, and these 2 terms may be written for a given problem for which we are solving here, minus property going inside, momentum going inside. So, mV1 plus momentum going outside in x direction. So, mV2 cos of theta. By solving this equation, rest of the terms are known to us, like we know P1, we know area 1, we know P2 A2, we know V1, we know V2, right. So, with the help of this equation we can find out the only unknown, which is Fx here. So, we can find out Fx. Similarly, we can write the equation in y direction for calculating the force in y direction. So, how do we write equation in y direction? Equation in y direction is equal to, first we have to find out the force in y direction. So, what is the force at this and 1, 2 in y direction? It has no component in y direction. So, 0. What about this force? This force will have component in y direction. So, P2 cos theta in x direction and P2 sin theta in y direction, or that is in negative y direction. So, one is the P2 into A2 multiplied by sin theta, it is in negative y direction because it is in negative direction. Mg is also weight of the fluid element acting in y direction, this is also negative, only F y is assumed to be positive. So, F y is acting upward and m g is acting downward, and pressure force or surface force acting at surface 3 4 will be acting downward, and pressure force acting at 1 2 will not have any component in y direction. So, these are the forces.